How strong is the Iron Man suit's punch? In the film Captain America Civil War, Iron Man learned Winter Soldier, Captain America's best friend, killed his mother. Angry, he punches Captain America, sending him flying backwards. Iron Man augments his strength to superhuman levels. But I want to know how much is behind the punch, or in other words, how strong is Iron Man's suit? First, let's make some assumptions. Iron Man is punching with all of his strength. This will give us a good estimate of his actual punching capability. Second, this is a perfectly elastic collision. This means there is no loss in energy or momentum. Third, no other forces are acting upon them, with the exception of gravity. This means there's no loss due to heat or friction or any other type of force. Fourth, Captain America, because he's a super soldier, has a mass of 100 kg. We also know one of the variables. The mass of Iron Man's fist is 5 kilograms. This is because we know the composition of his fist and can do the addition of all of the constituent parts. Calculating Captain America's velocity after being punched. Captain America is punched and flies 10 meters in 1 second before hitting the ground, as shown in the diagram. He moves vertically down due to gravity. Captain America's initial velocity, his VCI, is 0 meters per second as he starts standing still. His final velocity is 10 meters per second. He travels 10 meters in 1 second. In any collision, momentum is conserved. Momentum is defined as mass times velocity. The initial momentum of the system is the mass of the hand times the velocity of hand plus the mass of Captain America times the velocity of Captain America, both their initial velocities. The final momentum of the system is defined as the mass of the hand times the final velocity of the hand, plus the mass of Captain America times the final velocity of Captain America. It can be rewritten thusly. We can substitute in our variables that we know and derive it down until we get a relationship between VHF and VHI. In this case being VHF equals VHI minus 200. We'll call this equation 1. Next is conservation of kinetic energy. Kinetic energy is defined as half times the mass times the velocity squared. We know the initial kinetic energy of the system is equal to the initial kinetic energy of the hand plus the initial kinetic energy of Captain America, and the final kinetic energy of the system is equal to the final kinetic energy of the hand plus the final kinetic energy of Captain America. Kinetic energy is conserved in a perfectly elastic collision. So we can rewrite that as an equation, setting initial equal to final. Then we can start substituting in our variables. We'll start with Ci, so we can get rid of this expression. Then we divide both sides by half and solve it by substituting in our variables until we get to this point. Then we can substitute in our value for VHF from equation 1. Then we can re-expand it and solve for VHI, which in this case is 105 meters per second. Then we can take that and substitute that back into our relationship from equation 1 to get a VHF of 95 meters per second in the opposite direction. Now we check it. In order to check it, we have to answer 2 questions. First, is momentum conserved? And if we looked at the math, yes, it is conserved. And we do the same thing for the question, is kinetic energy conserved? And we look at the math again, and yes, kinetic energy is conserved. Now we come to the real problem, finding the force of Iron Man's punch. Thanks to Newton's second law, we know force is equal to mass times acceleration, which can be rewritten as F equals m times a, which can then be rewritten as m equals the change in velocity over time, because that is equal to acceleration. So we know his hand's mass is 5 kilograms, and the change in velocity is 105 minus negative 95, which is 200 meters per second. Assuming the duration of the punch is 0.001 second, plugging these numbers back into the equation, we see that Iron Man yields a net force of 1 million newtons. Now that might not seem like a lot, but let's put that into perspective. Floyd Mayweather, the most decorated boxer of the modern era, has a punching force averaging 36,000 newtons, 3,600 newtons. So it's more akin to the SpaceX Falcon 1 lifting off, which also has a force of 1 million newtons. So if you get hit with this, you're waking up with one heck of a bruise in the morning.